Ramanujan for G is now available on the Google Play Store. Try it out for free.
So good morning, students. So we have started our basic nomenclature of organic compounds in our last class. We have started with some trivial names, so the common names. And but we know some of the compounds are still known with their common names. That those common names are so famous that one cannot avoid them. Like some examples we have seen, like the methane, propane, methane, ethane, propane, butane. These are all common names, and these common names are very famous. And these names are so famous that some of the meth, eth, prop, but, these are these root words. These are also considered as numerical prefixes or the numerical roots that we consider in naming organic compounds. And some other compounds, the common names that we also know they are important. You should also remember these names like aniline. Then similarly, NH2 group, these things I have explained. We can have phenol as well, resource phenol, catechol, then the dihydroxyquinone, quinone, and these are the very other names. Is methyl ether, benzene, acetic acid, formic acid, acetaldehyde, formaldehyde. These molecules, perhaps you know these common names. They are very important. Although you can write their name like methane is now also considered as a IUPAC name in the IUPAC nomenclature. It's IUPAC name as well. Although it was a common name initially, it started with the common name. So anyway, you can also name these compounds as per the IUPAC nomenclature, but you should instead of that you should also know that what are these common names, and these common names represent what kind of compounds, because the questions may be asked based on the common names as well. So we started IUPAC nomenclature. Few basic rules we have studied. What we have studied is in the organic compound, what we have to do is you have to identify the functional group, and in the functional group, the principal functional group, and then what is the longest continuous chain, means the parent chain or the main chain or root chain or the principal chain, whatever you can call. These are the principal chain you have to find out, or the main chain or the root chain you have to find out, means you have to identify. Then the principal functional group, and then substituents for the branches what are there. This other functional group other than the principal functional group, the subsidiary functional groups are also considered as branches or the substituents of the this organic compound, the major, the longest chain. So we started first of all the IUPAC nomenclature of straight chain hydrocarbons. Straight chain saturated hydrocarbons, I should say rather. So straight chain saturated hydrocarbons. So naming them is very easy, because straight chain means you have only one chain. There is no branching in these organic compounds. No branching, no side chains. So naming such compounds are very easy. And what do we have to do? We have to just follow. We have need to one prefix and one suffix. So what is the prefix in this case? It is determined by the number of carbon atoms that is present in the compound. And the number of carbon atoms, which is one, only one. So then we call the prefix will be mate. If it is 2 H, 3 prop, 4 but, 5 pent. Now here onwards the numerical prefix that we get from the Greek roots that we use, or the Greek numerals that we use. The pent means 5 in the Greek numerals, hex means it comes for the 7, sorry 6, hep for the 7, op for 8. Here we use in is in the Greek numerals, and in the place of that we use non, then the dec. These are the, and the I cos, I cos it represents 20, and the undec, dodec for the 11, 12, and this triacon 10, it represents triacont, it represents 13. Triacon 10, tetracon 10, pentacon. So it represents 40, 50, like you know. What is tri, tetra, penta, hexa, something like this. It goes up to 9. So means 90. So what I mean to say, and then in naming these compounds, what do? We add a suffix n. So if there is a carbon number of carbon atoms is only one, it is methane. If it is two, so we use eth, the numerical prefix, and then ane to represent this straight chain saturated hydrocarbon. These names we have already seen, and I think I should start with the branch chain hydrocarbon. Here also we have studied about few basic things. Like we must understand what is the primary carbon, secondary carbon atom, tertiary carbon atom, quaternary carbon atom, or if the substituents are there, what is the primary, secondary, tertiary substituents. So here what I have already explained that if the one carbon atom is directly linked to one carbon atom, then it is a primary carbon atom. If a carbon atom is linked directly to two different carbon atoms, then it is secondary carbon atom. And if a carbon atom is directly linked to three different carbon atoms, like here, this is a tertiary carbon atom. And if a carbon atom, or this is also a tertiary carbon atom, this is also a tertiary carbon atom, although these are the substituents. This will become a quaternary carbon atom. It is attached to the main chain because we know here is a vacancy and this valency is empty. This carbon can bind to another carbon atom or in the chain, then this will become quaternary carbon atom. But in this branch or the side chain, it is still a tertiary carbon atom. And this one is a quaternary carbon atom. Even if it is attached to the main chain or the root chain, we know this is the alkyl group. So it will attach to this carbon atom. So the number of carbon atoms attached to this carbon is not going to change. And anyway, what we know, the quaternary carbon atom is the carbon atom linked to four carbon atoms. This cannot go more than four because carbon has only four covalency. So these things we already know. So in the branch chain hydrocarbons, to name them, we have to identify first what is the root chain or the main chain and what is the branch or the side chain. To understand that, we have to identify first the longest continuous carbon chain. And this longest continuous carbon chain is called principal chain or parent chain or the root chain or the main chain, whatever you can say. And then some small branches are there at different carbon atoms, and these branches are small chains are called alkyl groups. They are named as alkyl groups, and why they are named as alkyl groups? Because if suppose in this carbon chain, if this you consider this compound, this is the alkyl group, this alkyl group is the methyl group. And what we actually this was methane, and in methane we have substituted one hydrogen with this main chain. Or in this main chain, if this was CH2, then there was no position for CH3. So in this main chain, we have replaced one hydrogen to attach the CH3, means we have replaced one hydrogen with CH3 group. So this group, because it has originated from the alkane or the saturated hydrocarbon, so in naming such groups, what do? We just remove ANE of that alkane's name and we add YL at the end. And so this way we name the substituents. Like if the methane was there, if this was methane and now it has become one hydrogen is replaced or substituted with this parent chain, so this substituent or the branch is called methyl. So one can name in the IUPAC names, we use it as a, its name, this substituent as a methyl group. And this substituent CH3, CH2, uh, earlier it might be CH3, CH3, which is ethane. So this is from the two carbon atoms. So from this has originated from two carbon atoms, alkane means ethane. So this the name of this substituent will be ethyl. So if there are three carbon atoms in a substituent, and if it is a linearly connected, then it will be propyl. It is butyl or n-propyl, n-butyl. People also say decane, decyl. If it is there, what do we also know? One thing you should remember, some abbreviation for the alkyl groups are also used, and abbreviation Me is used for methyl. Either you can write CH3 or sometimes people also write in place of CH3 Me. If Me is written there, it means there is a methyl group, means it is CH3 group that is connected to this carbon atom. And Et is used as abbreviation for ethyl, PR for propyl, and Bu for butyl. These names are important. Bu, so suppose if Bu is written here, it means it is in butyl that is connected there. If it is IBU, means isobutyl. TBU, people write it means tertiary butyl. So these substituents are written like this. So we know the isopropyl can also be there. So people also write IPR. I they write as the superscript, left superscript I, and then PR. It means it is isopropyl group that is connected to a given at a given position in that organic compound. So at this position, suppose this position, this CH3 is replaced with isopropyl. So the people either can write this entire group or they can also write I as a left subscript, left superscript. So if it is tertiary butyl, if it is again TBU, then it means tertiary butyl. It means this group was linked to this carbon. If it is isobutyl IBU, it means this group was attached here. Means this group was attached at this carbon atom like this. And secondary butyl SBU, so it is or the sec BU, people write sec BU, so it will be like this. Anyway, so what do we also know? The sum of the alkyl groups can be branched as well, and these branches are some common names of the branches are there based on the and this common names what we know if is the state chain, this CH2, CH3, this is propyl or N-propyl, and if this isopropyl group, it means if this group main chain is this propyl group is attached to the main chain at one of the terminus, then it is propyl substituent. And if it is attached with the main chain in the middle or middle through the middle carbon, then it is called isopropyl. So this middle carbon, so middle carbon it is connected to the main chain or the root chain. Now the secondary butyl, we know this is the secondary carbon atom in this alkyl group or the butyl group. This is secondary carbon atom, so this is named as secondary butyl. So from the secondary butyl, so main chain, this is linked to the main chain through this carbon atom. So this is a secondary butyl. The secondary butyl name is also used in IUPAC nomenclature. Isopropyl people also use this names to prefix to name these branches in IUPAC nomenclature. So these names are important. There is also certain rules which one can use in writing IUPAC nomenclature, but you should remember but that these names, the common names, are also directly used in naming organic compounds according to IUPAC rules. So now this is tertiary butyl, this is neopentyl, the neopentane group we know it. If it was CH3, this was neopentane, now CH3 in the place one hydrogen atom is replaced because this is removed because this carbon atom is attached to another carbon atom of the main chain. So one hydrogen is less here. And so these things up to here we have already understood, we have read. Now let us start this how one can identify the main chain and how one can do the numbering and how we will write the name of the branch chain saturated hydrocarbons initially that we will see. And this for to do that we have to first identify the longest chain, longest carbon chain or longest continuous carbon chain in the molecule. So this is only for the alkanes, the saturated hydrocarbons, the rules we are going to follow. And although these rules are for the saturated hydrocarbons, so the similar rules will be followed for all the organic compounds, even those compounds which contains a functional group. So these rules are basically going to be followed similarly into the even any organic compound. So you should pay attention to what we are going to study. So what we have to do, we have to first identify the longest continuous carbon chain in the molecule. So longest, for example, if this compound is given here, so how will we find the longest continuous carbon chain? So if we go from here, we start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. This, if we can go also down from 6, this is 7, this is 8. So one can also number this according to this. But what do we find? If you go down, the number of carbon atoms in this chain will be only 8. So this cannot be considered as the longest continuous chain. To consider the longest continuous chain, it doesn't mean you have to go in the straight line. You may follow any path and you can go to the can reach to the longest continuous chain. The continuous means there should be a bond between direct bond between the carbon atoms which we are going for in the forward direction. So these carbon atoms, the continuous carbon, there are only 8 groups. So this cannot be the principal chain or the main chain or the longest continuous chain. So we cannot consider this as the longest continuous chain or the main chain or the root chain or the parent chain or the principal chain. So this is the longest contains the longest continuous chain, and what we see these small chains are there and these are considered the branches. This is the ethyl group and this is methyl group. So there are two branches at this position. In this position, even if you consider it, there are also two branches, and this branch is propyl group and this branch is methyl group. What can we do? We can also go from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Even if you go from here, the number of carbon atoms in the longest chain is still same, and what we see, the branching is still at the second position. So either you go from one to this direction or this direction, there is no difference. So you go here through this or this is those two things will be identical, so there is no difference between them. Now the next rule is a number. So we have to then once we identify the longest continuous carbon chain or the main chain, the principal chain, the parent chain. Then we have to do the numbering. We have to number all the carbon atoms, and to number all the carbon atoms, we have to follow certain rules. To number the carbon atoms of the parent chain, to identify the parent alkane, we have to identify the parent alkane, and also to locate the positions of the carbon atoms at which branching takes place due to the substitution of alkyl groups in the hydrogen atoms. So what do the alkyl groups substituted the hydrogen atoms of the main chain at certain positions, at certain carbon atoms? We have to identify those positions as well at which the hydrogen atoms are substituted by certain alkyl groups. So in this compound, this is the wrong one. So we will consider the first one. So in this, what we have seen in this compound, at this position, a branching has taken place, and this branching is one hydrogen is replaced with the methyl group, and at this position also one hydrogen atom is replaced with the ethyl group in this case. So the branching is also taking place at this position as well. So to identify at what carbon atom the branching has taken place, and also the how many atoms are there in the longest chain, to identify the longest chain, we do this numbering. But the numbering, if in what direction one should do the numbering, I can also do the numbering from this side. 1, 2, 3, 4, 5, 6, and up I can reach 9 up to here. But we go follow the numbering in this direction. But what is the reason for this? And the reason behind this is written here. The numbering is done in such a way that the carbon atoms at which branching takes place get the lowest possible numbers. So at whatever the positions branching is taking place, those carbon atoms should get lowest possible numbers. In such manner, the numbering should be done. So if suppose if the numbering is done in this direction, means the branching has taken place at the second carbon and the sixth carbon atoms. Second carbon and sixth carbon. And if you do the numbering from this direction to find the longest continuous carbon chain, so 1, 2, this 2, 3, 4, at the fourth position, the branching has taken place, and then at the eighth position. So it will be fifth, sixth, seventh, eighth, and then ninth. So at fourth and ninth, instead of fourth and ninth, we will follow the branching at second and sixth position, because then these branches gets lowest possible number if we do the numbering in this direction. So we will follow numbering in this direction. This rule we will follow. And the rules you can see, numbering one can do that is the same organic compound, only we have written only the skeletal, the carbon atom. So the skeletal structure, hydrogen atoms we have omitted, and we can do that also to represent organic compounds. And even if we have written this, it means this is there in our mind that all the carbon atoms have tetravalency, and those valencies are completed because of the hydrogen atom. It means this carbon atom is linked to three hydrogen atoms. This one is to two hydrogen atoms. Then was this one to one hydrogen atom only. So these things, this understanding is there to us because of the chemical bonding, that we know the covalency of carbon follow tetra covalencies and so on. So if you do the numbering, what we see, the branching is taking place at fourth and eighth position, and in this fashion branching taken place at second and sixth position. So this way of numbering is wrong, and we will follow this one because branching is at the lowest possible numbers. So now the rule number 3, you should understand this. If the substituents are substituents are there, we'll follow the numbering in the direction so that the substituents get the lowest possible numbers. The third rule is the names of alkyl groups attached as a branch, this is for the branch, are then prefixed to the name of the parent alkane. And then whatever these alkyl groups are there, and what we have seen for the straight chain, we have for the straight chain in the naming, straight chain hydrocarbon. Sorry, uh, we have seen that this is the this is a prefix. The prefix depends on the number of carbon atoms. So to this prefix, the methane, ethane, butane, these alkyl groups will write even before those names. So what is the number of alkyl groups attached to the branch are prefixed? Sorry, the names of alkyl groups are prefixed to the name of parent alkane. So parent alkane, these 9 carbon atoms are there, so it is nonane. And nonane and these alkyl groups, their names will be prefixed, means it will be put before the name that are the word that we use, the no name. So it is before that it is written, and the position of the substituent is also indicated in their by their locations on the parent chain. And also not only that is not only sufficient that we use methyl and ethyl in naming the IUPAC nomenclature, it is also important to write the positions at which these groups are attached to the main chain or the parent chain. So this methyl group is attached to the second carbon, so we'll write 2 to represent that this carbon atom, this methyl group is attached to the second carbon atom, because this methyl group can be attached to this carbon atom as well, this carbon atom as well. So these positions we can say we will get, this is called, if we replace this, put this at this position, we can say that these are position isomers, because in the position in the carbon chain their position is differing. This ethyl group can also change its position here, here, here. Not here. If it will be here, then it will be part of the longest continuous chain, because then we will have to put numbering 8, 9, 10 here, and this will be the substituent. And if this carbon atom will be on the this carbon atom, then this will be part of the main chain and this will become decane. So I hope you understand. So this cannot be other than that, this position, this position, this position, this position, this position, anywhere this can go. And this one can also go to any position, this position, this position, this position, this position, anywhere. So this position, so at least one, two, three, four, four position isomers for the ethyl group are there. So we also name to represent that they are uniquely, all the position isomers they are named uniquely because they are different compounds. Their chemistry will differ slightly. So to name them uniquely, we follow these rules, that we also indicate their position or the position of the substituent by their locations on the parent chain. And if different alkyl groups, but while doing this, we have to take care of few more things. If different alkyl groups are present, they are listed in alphabetical order. But in the naming them, if the different alkyl groups are there, we name them according to the alphabetical order. So this is ethyl. Ethyl name starts with E and the methyl with M. So in the alphabetical order, ethyl will come first. So in the naming this compound, we will write the name, this one or this prefix will be written first, then this prefix, because those both of them will be prefixed to this main chain or the name of this parent hydrocarbon. So what do we write? If you want has to write the IUPAC name of this compound, what will we do? This ethyl group is attached to the sixth carbon atom, and this E is, this will come in the alphabetical order before the methyl. So we'll write 6 ethyl. So 6 ethyl. Then we'll write 2 methyl, because this should also be prefix. So 2 methyl, and its position is second position, 2 methyl, and then no name. And what you would note here is these letters are and numbers are, they are separated by hyphens everywhere. So 6, then hyphen, then E. So the numbers and letters are separated by hyphens. And if there are more numbers at the same position, like 2, 2, 3, or 2, 1, not 2, 1, 2, 4, or something like that, then these numbers are separated by comma. And these things, and what is the another point is the first letter is in the capital letter here, E. The first letter in the IUPAC nomenclature is the capital letter, and another point is that there is no space between methyl and nonane. In fact, there we have not put any space from here to here. The entire name should go in continuum. So from 6 to E, the last letter, and name starts from this position. There is no gap. These hyphens, commas, whatever comes, they are all part of the IUPAC nomenclature. And so we don't put any gap in naming IUPAC name of any compound. So there is, from here to here, there is only one name, one word. One can consider this from here to here as one word, means one name. So note here that the numbers are separated from the groups by hyphens, numbers from the separated by hyphens from the groups, and there is no break between methyl and nonane. In fact, there is no break anywhere. And also the first English letter is in the capital, and this first English letter is in the capital. So these are the things that we also should take care of while writing IUPAC nomenclature. Then there comes the another rule, and this rule comes because there are many other possibilities. Based on the different possibilities, people have come with different rules. So if two or more identical substituents are present, so instead of, this is what we know, this was also methyl, this is ethyl, and this is methyl, and if this was also methyl, or this was also ethyl, then two identical substituents are there, so not, so in that case, what do? We don't write here 2 methyl and 6 methyl. What we do, because methyl groups are there, so two methyl groups are there at different positions, so we will write one or two, then again the numerical roots we use or numerical prefixes we use to represent two methyl groups are there. Two means di, so will we write dimethyl, trimethyl. So these numbers we will use. So if two or more identical substituents are present, then the numbers representing their positions and the positions of the substituents are separated by commas, and these things I have explained here. And as you can see here, 2 and 4, these numbers are separated by commas. These 2, 4. So this, the numbers are there, different numbers, we separate them by comma, and but we don't put any gap here. Now this comma and 4, there is no gap. If you put gap, it will be wrong. So numbers representing their positions are separated by commas. However, names of identical substituents are not repeated. So we cannot write 6 methyl, if this was methyl group, so 6, 2 methyl and 6 methyl. Because the methyl groups we are repeating again and again. Instead, what we do? We write dimethyl, but the positions we will write 2 comma 6 dimethyl. In this case, we could write. So 2, if this was also methyl, so 2 comma 6 dimethyl nonene, and 2 and 6 dimethyl means two methyl groups are there in the entire compound as a branch, two methyl groups, and these two methyl groups are attached to this parent chain at the second and the sixth position. Let us now see the example here. So this compound, if what we have to find out the longest continuous chain, so we can go from 1 2 3 4 5, or 1 2 3 4 5, or 1 2 3 4 5, anything, it is the same. So we'll go, can write this in the straight line, then one can follow 1 2 3 4 5. So the longest continuous carbon chain will have the 5 carbon atoms from the any direction you will, if you count. Then we see the branching taking place at the two positions, second and the fourth position. So these are all the methyl groups only. So these methyl groups, now when can the IUPAC nomenclature, this is the pentane. The main hydrocarbon is pentane. The root chain, the parent chain name will be pentane. But this parent chain is also at different positions, different substituents are attached to it. And so at what positions? The second position and fourth position, two methyl groups are there. So for two methyl groups, we will write dimethyl. And then at what positions? 2 and 4. So 2 comma 4. And now the number separated by comma, and this number separated by a letter, English letter, or the word separated by hyphen. And we have not put any gap here as well. Dimethyl and pentane, you can see here. Then in this example, what do we do? So if you name again here, in this case, from any direction you go, you will find only 5 carbon atoms in the parent chain or the longest continuous chain. So any direction from here to here as well, or here to here, or here to here, here to here, or here to here. What can we do? We can also do the numbering from this direction, but in this direction we don't do. The reason I will see. And with the numbering, one can write from this direction. And why this thing we have already seen. What we'll see, there is the, if numbering will be done from this direction, 1 2 3 4 5, because if you do the numbering from this direction, 1 2 3 4 5, so what will we see? The branches are at the two branches are at the second position. So one, this methyl at the second, this methyl at the second position, and this methyl at the fourth position. If you go from here, this methyl is the second position, and the fourth position two methyl groups are there. So this numbering in this direction is not preferable, because we will try to put these numbers or the branching at the lowest possible carbon atom. So in this way, two methyl groups are getting the lowest position. So we'll do the numbering in this direction, and this rule we have already seen here. The numbering is done in such a way that the carbon atoms at which branching takes place gets the lowest possible numbers. And so the numbering will be done in this fashion. And what we do, what we see now, the branching three methyl groups are there as a branches, and these three methyl groups is the trimethyl. So we can write trimethyl pentane and T in the capital letter. First English letter we will write T as a capital letter. Here we have written D as a the capital letter. And now the positions of these branches we have to also mention, and these two and two. This two methyl, this methyl group is at second, and this methyl group is also at the second position. So two, comma, then four we write at the fourth position. Also there is a one methyl group. So two, comma, four hyphen trimethyl pentane. And these numbers one can also see the possibility 4 comma 2 comma 2 or 2 comma 4 comma 2, but usually we follow this in the increasing number. So 2 comma 2 comma 4 are these two there is no distinguish no difference, so no distinction. So this 2 comma 2 comma 4 we follow here, 2 comma 4 not 4 comma 2. These things you should also understand. Now the what means however the names of identical substituents are not repeated. Instead, the numerical prefixes such as di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, the same thing that we have seen here, in this table. Hexa, hepta, octa, nona, deca, icosa, and so on. So this numerical prefixes deca, nona, etc. are used. Now, the another point that is important to be noted here is while writing the name of substituents in alphabetical order, these numerical prefixes are not considered. While means if you are writing the IUPAC names, and if the different substituents are there, different branches are there, the different alkyl groups are there as a branches. So while writing the IUPAC nomenclature, we have seen we follow the alphabetical order of the alkyl groups, names of the alkyl groups. But these numerical prefixes, then once this comes dimethyl, means this is dimethyl group, trimethyl group. These numerical prefixes are not considered in writing the IUPAC nomenclature to find out the alphabetical order. And why? And one can see this example here. So in this example, the longest continuous chain is from here to this position 1, 2, 3, 4, 5, 6, 7. It contains 7 carbon atoms and numbering will be in this direction. Because why it numbering will be in this direction? Because at the third position, the branching and the fourth position branching is taking place. If you do the numbering from this direction, branches will be at the fourth and fifth position. So this direction will follow the numbering. So the branching will be at the third and fourth position. And in this direction fourth and fifth position. So this way we will do the numbering, and now what we see at the fourth position two dimethyl groups are there and two methyl groups are there. So two methyl groups will become dimethyl, but this di is the numerical prefix, the name, the word that represents the numerical prefix, we should not consider for the alphabetical ordering of the substituent. So D we will not consider for alphabetical ordering, because if we consider dimethyl will come first, then the ethyl, but that is not considered. These numerical prefixes are not considered anywhere. Even when we see the here what I have said, there is a secondary butyl. This secondary sec, it represents the number, this carbon atom. This is for the two. When it represents this carbon atom is connected to two different carbon atoms. So this will also not be considered. Tertiary will not be considered, but isobutyl, this I will be considered in the alphabetical ordering. The neo, N will, this entire thing will be considered in this alphabetical ordering, but this start means this whatever any number, any word that represents the numerical numbers, the numerical prefixes, that will not be considered for the alphabetical ordering. So these things you should also take care of. And now what we will do, the name of this compound will be then 3-ethyl, and the third position 3-ethyl group is CH2, CH3. 3-ethyl, then 4,4-dimethyl, because two methyl groups are there. So dimethyl and these methyl groups are at the fourth positions only. So 4,4 dimethyl. So you see comma and then hyphen between different letters whenever letter and words are separated by hyphen. Here also first letter is in the capital letter and there is no cap at all. So this is 3-ethyl 4,4-dimethyl heptane. Now the rule number 5. Just give me 1 minute. Hmm. So this rule number 5, if the two different substituents are found at equivalent positions, give the lower number to one that comes first in the alphabetical listing. What does it mean? If you see here, no, not in this compound we know, at the same positions in this direction, if you go, this ethyl group will get the third position and methyl group sixth position. And if this direction we follow, we'll get this methyl group is at the third position and ethyl group is at the sixth position. So if this direction you start the numbering, this branching is at the third and sixth position from any direction. What we have seen initially, this rule, the numbering is done in such a way that the carbon atoms at which branching takes place get the lowest possible number. But in this compound, in any direction, what we are seeing, the branching is getting at the same position. Third, in this direction, third and sixth. In this direction, also third and sixth. If this was the same branch of either ethyl or methyl, there was no difficulty because they are the same branches. But if they are different branches, then what we will do, from which direction we will do the numbering and which one will give the lower positions, that will be determined based on the alphabetical order. So this ethyl comes, E comes first, and so we will do the numbering from this direction. So ethyl will get the lowest position. So 1, 2, 3, 4, 5, 6. So this is the way we do the numbering for such compounds. If this methyl group was at this position, suppose at the second carbon atom from the right hand side, then we would have done numbering from this direction. 1, 2, 3, 4. So this would have been 6 ethyl and 2 methyl. But since these are at the same position from the different directions, so we'll do the numbering from this direction. And so 1, 2, 3. So this becomes 3 ethyl, 6 methyl octane. So 3 ethyl, 6 methyl octane. And if you write something like this, the numbering, you do numbering 1, 2, 3, 4, 5, 6 means 6 ethyl, 2 methyl, then this will be a wrong name and that you should not do. And let me just correct it. So this the name of this compound will be 3-ethyl 6-methyl octane. So why it is so? Because these branches, they are different branches and these different branches from different directions are getting the same looking, and so this numbering will be done based on the alphabetical ordering of the substituents. Now the rule number 6, what we have to do, the branched alkyl groups. This is for the branched alkyl groups. Here also I have said the same thing. This branched alkyl groups, these are branched alkyl groups. There is a one branch here. Though this was part of the branch, but this is also branched. This is also branched alkyl group because we see the branching. This is also branched alkyl group. So these branched alkyl groups, this rule is for the branched alkyl groups and how one can also name them according to rules that we follow. Can or this branched alkyl groups or substituents can be named by following the above mentioned rule. Whatever the above mentioned rule that we have seen means we have to do the numbering of this branched alkyl group. And the numbering, the only thing that we have to remember here is numbering will always start from the carbon atom that is connected to the parent chain. So since this carbon atom, we know that from this dash hyphen line, this vacancy is there. So this was connected to the parent chain. So we'll always start numbering from this position. And then we'll find out the longest carbon chain in this as well. And we'll have to follow in whichever direction we will go and we find the longest chain, then ethyl, methyl, all the alphabetical things that we have to follow. And the names, whatever the APC name with the rules we have followed earlier, if suppose this was an organic compound and this was CH3 group, not CH2 here. So not if the CH2 group was there, then this numbering up to here, this will the longest carbon chain will be the number of atoms will be 5. So suppose this is what we see, and with this was here, this you can consider 3 methyl butyl. But we see here that because of the branching at the first position also there is a branch. Usually in the organic compound, the parent chain, we do not see branching at the first position. If you see the branching as the first position for the parent chain, it means you have chosen the wrong parent chain. Means this should have been part of the longest chain or longest continuous chain. But in the branched alkyl groups, you can have the branching even at the first position, because what we know, the first position is determined by the carbon atom which is connected to the parent chain, and this carbon atom is connected to the parent chain, and there this hydrogen could have also been replaced with another alkyl group. So there would have been two branches, two methyl groups at this position, and this can be even the ethyl group. So and so on. I hope you understand this point. So to name these compounds, while we will have to do this branching is the two methyl groups are there as a branch in this alkyl group. So we'll write 1 and 3 at this branching are at the first and third position. So 1, comma 3 dimethyl, and these two dimethyl. Then four carbon atoms here, so dimethyl butyl, and we put this prefix this for the branched hydrocarbon in the parenthesis, and in parenthesis whatever this we write, it means this alkyl group has a substituent, it has also the branches. That is why its name is written in the parenthesis, and so we separate it like this. So name of such branch chain alkyl group is placed in parenthesis while naming the compound. This I have already explained. So while writing the trivial names of substituents in alphabetical order, this point I have explained here already. So this point, but we can see it separately. While writing the trivial names of substituents in alphabetical order, trivial names means the common names in alphabetical order. And as I said, if the branches are there, you can also do this, follow this rule to name this branched alkyl group. Or what can you also do? The branched alkyl groups, you can also use the trivial or the common names. You can write the secondary butyl, isobutyl, tertiary butyl. Or what can you do? This branched carbon chain will be, the number will be here 1, 2, 3. This is the 3 methyl propyl. This is what 1, 2, 2, 2, sorry, 1, 1 dimethyl ethyl. This is 1, 1 dimethyl, because no 1 or 2 or 1, 2 anywhere. 1, 1 dimethyl propyl. This is 1, 2, 3, 2, 2 dimethyl propyl. This is sorry, I think I have made error here. This is 1, 1 dimethyl ethyl, because 1 or 2, only 2 carbon atoms are there in the main. Here 1, 2, 3. This is propyl, and this branching as the second position. 2, 2 dimethyl propyl. This one will be 1 methyl ethyl. This will be what? 1 methyl propyl. This is 2 methyl propyl, because 1, 2, 3, 2 methyl propyl. This is 1, 2, 3, 1 methyl propyl. So either that name you can follow, or you can also use this trivial name: secondary butyl, isobutyl, tertiary butyl, neopentyl. So what this rule said, as earlier I said, that the sec word will not be used, SEC will not be considered in numeric alphabetical ordering of the substituent. Sec or tert, anything which represents the numbers, will not be considered. ISO do not represent number. This is the part of the common name, or this ISO or neo. So this will be considered in the alphabetical ordering, but not secondary, tertiary, or sector, or something like this. That those things will not be considered in alphabetical ordering of these substituents. So while writing the trivial names of substituents in alphabetical order, the prefixes iso and neo are considered to be the part of the fundamental name of alkyl group. So they will be there considered in the, they will be considered in the alphabetical ordering. So they will be part of the fundamental name of alkyl group. However, the prefixes like sec, tert, these are not considered to be part of the fundamental names, because these names represents a number. This prefixes represents number. Sec, it is like di 2. As earlier we have seen, di will not be considered as the means this is also numerical prefix. That di was also numerical prefix. Tertiary is also numerical prefix. So this will also not be considered as the part of the fundamental name of the alkyl group. The use of iso and related common prefixes for naming alkyl group is also allowed by IUPAC nomenclature long as these are not further substituted, as long as this isopropyl group, isobutyl group, neopentyl group, if there are no further branching, then these groups are also considered to be part of the, they can also be considered in the IUPAC nomenclature as I have said earlier. So, for example, if you we have not seen till now, we have not seen any such example. We'll see later on. So, what does it mean? And so, now in the multi-substituted compounds, what we see, the compounds can be multi-substituted. Multi-substituted compounds we have already seen. This is also a multi-substitute. This is also a multi-substituted compound. This is not the multi-sub. This is just a branched alkyl group. This is multi-substituted compound. This is also multi-substitute. They are all multi-substituted compounds. The multi-substitute, there is more than one substitution. They are multi-substituted compounds. So in multi-substituted compounds, the following rules may also be remembered. And these rules are if there happens to be two chains of equal size, and there means there is possibility in the multi-substituted compounds that the two chains of the equal size may be there. Then the chain is to be selected which contains more number of side chains. In such a case, we have to select that chain as a parent chain which contains maximum number of substituents. And for example, if you see this compound, if you go from here in this direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from this direction we get 10 carbon atoms. In this direction, if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from here in this way also 10 carbon atoms are there that can be part of the parent chain. From this direction we also get the 10 carbon atoms in the parent chain because we will have to start numbering from here anyway. So what we do, we consider this as a main chain of the parent chain, because if you consider this chain as a main chain, what we see that there are three substituents, two methyl substituents at the third position, and one more substituent, the branched hydrocarbon, a branched alkyl group at the fifth position. However, if you go in this direction, you see there is only one there is one ethyl group at the third position, and at the fifth position there is one branched alkyl group. So only two substituents will be there if you consider these carbon atoms as a part of the parent chain. Only two branches are there, and if you follow these carbon atoms as a part of the main chain of the parent chain, then you will have three different branches. So this will be the part we'll have to consider this carbon chain as a part of the main chain. And the numbering we have done in this direction, because if you do numbering from here to here, substituents will be at the fifth and seventh positions. If in this direction you go, substituents will be at the third and fifth position. So numbering is done in this direction. And so to name this compound, what will we do? So we have to find this is 1, 2, 3, 4. This is what the butyl group, and and this is actually ethyl butyl. So E will come. So this branched hydrocarbon is ethyl butyl. So E will be coming first than methyl. So this name should be first, and the numerical positions we do not follow. So what we see a branching at the fifth position. This branching is the branched hydrocarbon, and we know how can one can name the branched alkyl group. And this branched alkyl group fifth position. What we will do? So we will number this branched alkyl group, and the branching will numbering will start from the carbon atom which is connected to the parent chain directly. So this carbon atom is connected to the parent chain here, that as you see here. So numbering will start from here, and this is the common rule. So one, and this is only for the branched alkyl group, not for the main chain. For the main chain we see other rules. The lowest possible numbers or the locant should be given to the alkyl, to the branches or the side chains. Even if their different side chains are at the same positions, then we follow alphabetical order and so on. So what we do, so this is 5, and then in this branch chain at the second position there is one ethyl group. The branch alkyl group has a branching. So 5, then dash, then in parenthesis, what is the substituent? And this substituent is 2-ethyl butyl. 2-ethyl butyl, and after 5, this 2-ethyl butyl, as I explained earlier, here 1,3-dimethyl butyl. So this entire name of this branched alkyl group will be in parentheses. So this is put, it has been put in parentheses. Then hyphen, and now we will write these two substituents and prefix before the name of the main chain. And this is 3,3-dimethyl. So 3 comma 3 dimethyl, and this is decane that we know. So this is the name of this IUPAC name of this compound. And if you write this, you just consider this as a part, and you write this name means at the fifth position, and then numbering will be 1, 2, 3, 4. So 2,2-dimethyl at the fifth position, 2,2-dimethyl, then butyl, and 3-ethyl decane, then this will be the wrong one. Although both the direction we see the number of carbon atoms are same, and number of carbon atoms are same, but what we'll see, the case where the number of branches are more, that will be considered as a part of the parent chain or the main chain. So this name is the wrong one. This is the actual IUPAC name of this compound. Let's see other examples and how one can write the IUPAC name of this compound. So these also contains the branched hydrocarbon, and these are also, sorry, branched alkyl groups. So there is also branched alkyl group. We see here the branching is at this position, and we also know this is a secondary butyl. If you see this, at the secondary carbon atom, this butyl group is connected to the parent chain, and secondary butyl group you have already seen here. The secondary butyl group, and this carbon atom, secondary carbon atom, this group is attached to the parent chain, so the secondary butyl. So from this you should not be confused. One, I can also write this in the straight direction, and then one I can show this hyphen at this position, or maybe the downward direction. So this understanding you have to make. So this is the secondary butyl group, and this one is what? This is isopropyl group. You can see here isopropyl CH, CH3 twice CH, and this CH group is attached to one CH3 and another CH3, two CH3 group, and this branch, you see the isopropyl group here, the isopropyl group CH and CH3 CH3. So this is isopropyl. This is isopropyl group. So as earlier we have seen this trivial name, secondary butyl isopropyl can also be used in IUPAC nomenclature if there is no further branching in these groups. There is no further branching that we see here. So we can also write this as isopropyl in the IUPAC nomenclature, or secondary butyl in the IUPAC nomenclature. But to do that, before we have to find out the longest carbon chain, and the longest carbon chain we will get in this direction. So up to 10 carbon atoms are there in the longest possible chain. If you go from here 5, 6, 7, 8, so this will be the 8 carbon atom only. So this cannot be part of the parent chain. So this is the parent chain. Now the numbering will be from this direction, because now these substituents isopropyl and secondary butyl group, they will get the position 4th and 5th. In this direction they will get the position 1, 2, 3, 4, 5, 6, 6th and 7th. So that, so numbering will be in this direction, and so what we get, this is the 4 isopropyl, and this is secondary butyl. And iso, I will be considered in the mm, alphabetical ordering, but we know this butyl sec will not be used in the, and if this sec was used, then we know this will come later, because this is secondary butyl, as it comes later than this isopropyl. But as we know, ACC will not be considered as a part of the in the alphabetical part of this in the alphabetical ordering. So we'll see iso I, and this is the butyl. So B. So butyl will come first. So what we do, we write the fifth position secondary butyl. So fifth position secondary butyl, and SEC, S will not write in the capital letter because this is just a numerical. This we write B as the capital letter. So 5 secondary butyl, and then for this 4 isopropyl and 4 isopropyl decane. One can also write another name for this compound, and what we will do, I can also write this as, I can do the branching here, 1, 2, 3. So this is propyl group, and this will be ethyl group then. And this 1, 2, and another carbon atom will be the part of the branch. So so this is ethyl, this is propyl. So ethyl will, and though and the substituents we see in this, I think, so there is just one error. So yeah, so what we will do then, the numerical order. So this is what ethyl group, and one branch will be there at the first position. There is one branch over two. So this will be 4, then 1 methyl ethyl, 1 methyl ethyl, 4 1 methyl ethyl, then fifth 1 methyl propyl at the fifth position, 1 methyl propyl, and this 1 methyl propyl, it represents this branched alkyl group or branch substituents. This also represents 1 methyl ethyl branch substituent, so they are written in the in parentheses and then decane. So this can also be the IUPAC name. This is also IUPAC name. Both are correct. Sometimes people follow because this is a smaller name, so people mostly follow this kind of names. And these names, if this becomes larger one, and so usually if the secondary, this means that these branches do not have the common name, they do not have further branching, we follow them directly in the IUPAC. The direct, the branched alkyl groups, they are considered also in the common names into the IUPAC nomenclature. Now what we see, this compound, 9 carbon atoms are there, and this branching is at the fifth position. And if it go in this direction, 5, 6, 7, 8, only 8 carbon atoms. So this is the main chain, and so we will consider this as the part of. And you just here, if the number, they do two directions, the number of carbon atoms are same, then only we will see the direction from which we get no more number of branches. If the number of carbon atoms are different, the chain with the highest carbon atoms will be the main chain or the parent chain. So this is the parent chain and not this one, although it contains more number of branches. So if this, we see the branching as the fifth position, and this position, this group is neopentyl group, and this group is neopentyl group. You see here, this is the neopentyl group. CH2, CH3, CH3, three different positions. This tertiary carbon atom, CH2, and you see here this group as well. So this is the neopentyl group. So one can write this as 5 neopentyl nonane. Or what can we do? This is a branched alkyl group, so I can also do the numbering 1, 2, and the second position what we see 2 methyl groups. So what can I write? 5 hyphen then 2 comma 2 dimethyl propyl. This is the propyl, and this 2 dimethyl. So 5 2 comma 2 dimethyl propyl, and then no name. No name. This is the name. So these both are the IUPAC name of this compound, and this is because two names are coming because the branched groups that we have used here, usually we follow this name. This name will be followed because these alkyl branched alkyl groups, they are there, and the trivial name, this alkanes, this was neopentane, and neopentane, one of the hydrogen is replaced, uh, and at that position the parent chain is attached or linked. So that name, the neopentyl group, is considered in the IUPAC nomenclature. This is more commonly used name. This will also be more common name, but even you can write based on these rules these names as well. Now let's see this some other examples. This example, if you come here, the rules that we have seen, the branching. If you follow from this direction, one, two, three, four, five carbon atoms. From this direction as well, one, two, three, four, five. But what we see, if you go in this direction, there will be only two branches. One, this one, the isopropyl group and methyl group. However, if you go from this direction, you get one another branch here, one branch here, one branch here. So this is actually the main chain or the parent chain. So this compound's name will be 3-ethyl here 2,4-dimethyl pentane. So 3-ethyl 2,4-dimethyl pentane. And this name that 3 isopropyl 2-methyl pentane will be wrong. Now let's see this one. This one, the carbon chain 1, 2, 3, 4, 5. So five carbon atoms. If you go from this direction, one, two, three, four, sorry, one, two, three, four, five, six. So this will be the part of the main chain. One, two, three, four, five, six. So this will be the part of main chain and not this one because this one contains only five carbon atoms. So this is the wrong notion. So what we will do is this is one, two, three, four, five, six. So the parent chain is hexane and the branching will be at the second and the third position. So two, three trimethyl, three methyl groups are there as a branch. One, two, three, two, three, three trimethyl hexane. So this will be the name of this compound, and this compound's name you can easily find out. This is one, two, three, four, and the branching as a second 2-methyl butane, or this is also isobutane. This name of this, so this name is isopentane. This compound's name is isopentane. Five carbon atoms are there. The common name. This was the common name. That IUPAC name will be 2-methyl butane. Then this compound's name, six carbon atoms in main chain. One, two, three, four, five, six. Even these two, if you go from this direction, also this will be there, and number of branches you go more from this direction. Suppose I hope you understand this point. What I said is one, two, three, four, five, six. If you follow, consider this chain as the parent chain, then you have two branches at the second and third position. And the number of atoms in the parent chain is 6. If you consider this C2H5, two carbon atoms of this, so 2, 3, 4, 5, 6, again you will have 6 carbon atoms in the parent chain. But in that case, there will be only one branch, that is isopropyl group. So this will not be part of the parent chain. We will not consider this the part of parent chain because the number of substituents now will be only one. So we consider this as a part of parent chain. So in that case, we will have two substituents. So number of branches are more. So this is 3-ethyl 2-methyl hexane, and why 3-ethyl 2-methyl? Because this CH2 C2H5 group can be here as well. So there will be position isomers. This methyl group can be here, 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 anywhere at this position. So the position isomers, these are called position isomers. Means if you get different compounds with the different and just by changing the position of certain substituents, then that is called position isomers. So this will be position isomers. Now this is the neopentane, that compound. We know the common name neopentane, and this neopentane IUPAC name will be 1, 2, 3. At the second position, two methyl groups are there. So 2,2-dimethyl propane. The propane, the main chain, the parent chain contains three carbon atoms, then propane, and the two substituents methyl groups at the second position, 2,2-dimethyl. These D should be capital, this E should be capital, this is M should be capital. Somewhere I have copied, so and I cannot change it anyway. Now here you should consider this letter. First letter should be in the capital letter. I hope you understand this. This D capital, E capital, M capital. So you should keep that thing in your mind. Now let's see this compound's name. This compound's name is, if you consider this, as I said earlier, the CH3. In the straight line, if you go, this is one, two, three, four, five, six. Six carbon atoms only. And then you will consider this as ethyl group as a branch and this propyl group as a branch. But that will be wrong notion. You should not do that because you have to find the longest continuous chain. And then we will have to start from here or here. And if you go in this direction, one, two, three, four, five, six, seven, eight. So eight carbon atoms will be part of this main chain. So this is the main chain, longest continuous chain, and not this one, or not even this one, or not even this one. So what will then comes the numbering? If you start numbering from this direction, one, two, three, four, five, six. So fifth and sixth position there will be branching. But if you start numbering from here, one, two, three, four, five, the third and fifth position of branching are there. So what we do that, so this way we start numbering, and so branches are at the fifth position, one ethyl group, third position, one methyl groups. So this will be five ethyl. This is ethyl group, five ethyl, three methyl octane. So this is the name of this compound. And now this compound CH3, CH2, CH, CH, this if you consider here. So this way we can also get same number of carbon atoms, 1, 2, 3, 4, 5, 6. This way also 1, 2, 3, 4, 5, 6. But if you go in this direction, we'll get only 3 substituents. We'll get, so this direction, 1, 2, and then third one. But if you go consider this, the carbon atoms as the part of the main chain, then what we get, 1, 2, 3, 4, four substituents. So we'll consider this carbon atom as the part and not this one that as shown here. This is not part of the main chain, these carbon atoms, because the number of substituents as you can see here are less, 3 only. In this case, number of substituents are 4, 1, 2, 3, 4. So this is the main chain, the parent chain. So now in that parent chain, the numbering, if it comes to the numbering, one can do 1, 2, 3, 4. Numbering, if you start from here, 1, 2, 3, 4. But the numbering of the all the substituents are at the same, 1, 2, 3, 4. Here also one, sorry, 2, 3, 4, 5, and here also 2, 3, 4, 5. But what we will get, the ethyl group that is different. The ethyl group will have to put the least number because the alphabetical order will decide. So what, 2 methyl, 3 ethyl, this we consider 4 methyl, 4 methyl, 5 methyl. If you go from this direction, 2 methyl, 3 methyl, 4 ethyl, 5 methyl. So this numbering we will follow. So this numbering if you follow, it will be 3 ethyl, then 2, 4, 5 trimethyl hexane, and the total number of carbon atom are 6, so it is hexane. Now let's see how one can write the IUPAC name of alicyclic compounds. Alicyclic compounds, we know it is aliphatic cyclic compounds. Aliphatic cyclic compounds, they are kind of the open chain hydrocarbons, but they actually the two ends are connected. They are not aromatic compounds. So the open chain hydrocarbons, they get connected at the two ends of them, they get connected. Then one can call such compounds as alicyclic compounds. So a saturated monocyclic compound is named, and only the monocyclic compound how one can name that we'll see, not a fused carbon chain or fused rings. Fused rings, two rings are connected with each other, or even if the two rings are there separated by some carbon atom. So those things are not there in our syllabus, but there are also rules for naming for both fused rings or the connected rings. More than two rings are there. So anyway, we have to. This is only cyclic compounds having only one ring is there only in our syllabus. So we will only see the naming or the IUPAC nomenclature of such compounds. So a saturated monocyclic compound is a monocyclic having only one ring. Mono means one. We know cyclic means cycle or ring. Compound is named by prefixing cyclo to the corresponding straight chain alkane. So what we see, this alkane, it contains 5 carbon atoms. So if it was an open chain hydrocarbon, we could have named it as pentane. But since it is a cyclic hydrocarbon and what we see there is no double bond, then we only put cyclo before the name of pentane, and this is a cyclopentane. So this means only, so prefixing cyclo to the corresponding straight chain hydrocarbon. The corresponding straight chain hydrocarbon for this have would be pentane. And so we put, since it is cyclic, we will write cyclo before its name, so it is cyclopentane. So if side chains are present, then rules given above are applied. So earlier rules, whatever rules for the straight chain hydrocarbons that we followed, the same rule we applied if the branching is there. And so what you see, the two branches are here in this compound. For the two branches, what we will so see, 1, 2, 3, 4, 5, 6. One can follow. This is a propyl P, and this is methyl M. So the numbering will be start from this position. And this position, because one can start, there is no, one cannot consider which carbon is the first carbon, and there is no end of this ring compound. So there is no clear cut end. So what we will do, we will start numbering from the carbon atoms which from at which the branching taking place. So I can, there we can start numbering from this position, and you can go from this direction or this direction. If you go in this direction, so 1, 2, 3, 4, 5 position, then another branching will be there. So this, and in this direction, 1, 2, 3. So this way one can go. However, this we cannot start numbering at this position, because this is a propyl group and this is methyl group. The methyls in the alphabetical order comes first M. So we will start numbering from this position, and we cannot go in this direction, because the next branch, if you go in this way, will come at the fifth position, fifth carbon atom. And if you go in this way, the next branch will be at the third carbon atom. So this is the proper way of numbering. So 1, 2, 3. Then one can even write 4, 5, 6. But that is not important for us, because this is total 6 carbon atoms. So this is cyclohexane. So like cyclopentane, if there was no branching and 6 carbon atoms was were part of the ring, then we can write such compounds, aliphatic cyclic compounds or alicyclic compounds, as cyclohexane. But this cyclohexane has two branches, and so this branched name of the side chains names will be prefixed to the name of the cyclohexane. So what now we write, 1 methyl, 3 ethyl, again alphabetical order we follow. 1 methyl, 3 propyl cyclohexane. One again mistake here, typing error. This 3 propyl. So 1 methyl 3 propyl cyclohexane. Now this compound, if you see here, this is ethyl. The ethyl, and these are two methyl groups for the cyclohexane. This is the cyclohexane is the main cyclic compound of the ring. And the branching, there are three branches. Two methyl groups are here at this carbon and one ethyl group here. Usually in the alphabetical order, E comes first. But what we see, if you start numbering from this position, 1, 2, 3, and the third position, two branches are there. So 3, 3, and if you, and at the first position one branch, and if you start from here at first position, two branches will be there, and third position only one branch. And so what we follow, we, this way the branches will get lowest possible number if we start numbering from this position. So branches getting lowest possible numbers, it comes in the priority than the alphabetical order. So if the two branches at the same positions, then we follow this rule. Because only one branch here, only one branch here, then here we followed alphabetical order of numbering. But in this case, we follow the more branched carbon gets lower number. So more branched carbon, this carbon gets lower number. So 1, 2, 3. So this is 3 ethyl, and in the naming we write ethyl group first, and 1 dimethyl cyclohexane. And this way one can write the IUPAC name of all alicyclic compounds having only one ring or one cycle in it. Now let's see this question, and then I'll stop. Here, so structures and IUPAC names of some hydrocarbons are given here. The two hydrocarbons are given here. Explain why the names given in the parentheses are incorrect. So names given in parentheses are why incorrect, and names given outside the parentheses are correct. This we have to explain. So let's say this hydrocarbon, the first A. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms one can consider as a part of main chain. And what is written in this? The octane is also written in the parenthesis. We have to explain why it is wrong. 3, 4, 7. It is given 3, 4, and 7. So numbering, it has started from this direction. 1, 2, 3, 4, 5, 6, 7. So 3, 4, 7 trimethyl octane, the name it is given. But what we see, if you do the numbering from this direction, 1, 2, 3, 4, 5, 6. So 1, 5, 6. Sorry, 2, 5, 6. 1 here, 2 here. So 2 and 5 and 6. So numbers, the branches, if you do numbering from this direction, the branches will get the numbers 2, 5, 6. If you sum these numbers, it will be a lower number than if sum gets sum these numbers. So one way to find out is different branches are there. Sum all the branches with positions, and you get in whatever direction the lowest number, you will start numbering. Start numbering from that direction. Here in this case, what happens? 1 plus 1, 2. If numbering starts from here, 2 plus 3, 5. If you do numbering from this direction, 1 plus 3, 3. 3 plus 3, 6 and 1, 7. So if you start numbering from this point 1, 2, 3, you get number 7. And if you sum the branch positions, and if you do numbering from here, you will get 2 and 3, 5 only. So this way we do the numbering. Here also what we see, 2, 5, 6. If sum 2, 5 and 6, this number will be lower than 3, 4, 7. And so this numbering will be from this direction. And this direction, so the name of this compound will be 2,5,6 trimethyl octane. So 2,5,6 trimethyl octane. So lowest locant number 2,5,6 is lower than 3,5,6, and that's why this name is wrong. In the next question, let's see. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms are part of the parent chain. And then you can, even if you do the numbering from this point, 1, 2, 3, so that is the same. So you may go this direction and this direction. Another point is this ethyl and methyl groups. This ethyl group at the third position and methyl at the sixth position from this direction. If you go from this direction, methyl is at the third position and ethyl is at the sixth position. So numbering, since if these substituents are getting the same locant numbers, and but they are different substituents, so what which direction will follow the numbering, that depends on the alphabetical ordering of the substituents, and alphabetical ordering of this ethyl comes first, so the numbering will be from this direction. So it will be 3 ethyl, 6 methyl heptane. Sorry, 1, 2, 3, 4, 5, fifth position. So 3 ethyl, 5 methyl heptane. And if you go from numbering was done from this direction, it will be 5 ethyl, 3 methyl heptane, and so 5 ethyl, 3 methyl heptane. But numbering, this way of numbering is wrong, because in that case alphabetical order, these locants are at the same position, and the alphabetical numbering is important. So this is the name given in the parenthesis is wrong because of that reason. I hope this was clear to you. So now, till now, we have understood how one can write the names of the branch chain saturated hydrocarbons. And from the next class, we will see the nomenclature of organic compounds having functional groups. So now the same, following the same rules with some additional points, we can write even the names of organic compounds having functional groups, and those things we'll study in our next class, coming class. Okay, goodbye.